All right, let's start the second day. So welcome. I am your host, Van Hartz, or known as BB, and I'm from the CERT.LV. I am the lead cybersecurity expert at our team, and I'm also the manager of this track. Now, over the last 2 days, well, including this is still not over, we've been going over the operational technologies, threat attribution, cyber threat intelligence, vulnerability disclosure, which is coming up now, and cyber exercises. I do want to remind you about the questions that you are encouraged to ask, and that we accept them in multiple formats, in multiple ways. The first one is, if you're shy, you can use the Menti code, which is going to be shown here, to ask the question and engage. The other one is you raise your hand during the Q&A session, and the microphone will be passed to you. And the alternative is always talk to our speakers, talk to each other, and get the most out of it. Now, with this introduction, I want to also introduce our first speaker of today, who is Dr. Stanislav Dashinsky from Forescout, and he's a security researcher there, with his research focusing on open source software, software security, and vulnerability analysis. And today, he's going to talk about routing network gateways.
Thank you. Hello and welcome. Thanks for being here. I really appreciate it. And its title sounds complex, but it's basically some experience I have accumulated over the years that will help you to get started with vulnerability research against various networking appliances. A little bit about me. I did my master's in automation and control systems, so it's very far from cybersecurity. I would say it's completely the opposite of that. And then, by some coincidence, I got into cybersecurity, namely the field of software security, and I cannot seem to find my way out. I've been working together with Francesco Laspina, who could not be here, on the content that you will see in the next slides. So it's our joint work, basically. And the things that we do vulnerability research against networking devices as our daily jobs. Right. So the bootstrapping probably was the wrong word. What I will use here is a term called routing, is essentially getting a root access on a network device for various purposes. And for us, as vulnerability researchers, this means that we can finally start our work. But maybe for some of the attackers, that's the actual end goal. So I will talk a little bit about this, and I will show you some of the interesting examples from the last couple of years. And of course, there will be some new vulnerabilities that I'm going to show to you today. Finally, I will tell you how we did that, and with a little of the demo at the end. Right, so why do people decide all of a sudden, let's root a router? And here I'm using the word router, but what I really mean is any box that sits on the network and can basically do or manage different kinds of network communications. For example, yesterday there was a presentation that mentioned edge devices, and those are different devices that sit on the edge of the network, and basically they give VPN access in and out of your organization. And if those are compromised, you are in trouble. And by nature, they are exposed online, so you cannot avoid that. The situation is that most of these devices, doesn't matter if it's a rugged enterprise VPN concentrator or a router you have at home, they are sort of closed down. Most of them run Linux, which is open source. They use a lot of open source components, but not all of them, if any of them, allow users to actually gain root access and to modify any of the software components inside. And the reason why I do this regularly is to facilitate vulnerability research, because static reverse engineering is cool, but in a complex operating system with complex binaries with thousands of lines of code, reversing statically, I can think of an analogy by, let's say you have to demolish a brick house, but you have only a teaspoon. You can admire the skill, but it's a little bit unpractical. So always do a dynamic reverse engineering if you need to understand complex protocols or how the binaries really work as a whole. So the reason for routing for me is so that I can install debugger and get sort of inside perspective of how things work. Often the firmware is encrypted, so it's sort of a chicken and egg problem. So if somehow you can root, you can get the decryptor binary so you can decrypt the rest of them, or you can just dump the file system and continue with your work. Of course, it's also for exploit development. If you have debuggers, the job is much easier. And like I said on one of the previous slides, for most people, that's the end goal. For me, it's just the beginning. Because what we do at Forescout, we actually provide exploit detection, mitigation, and also basically the visibility over the network. So we have to know how these proprietary networking protocols work. And for some people, it can be for fun. For example, you have a node router that is still good, but it's end of support. So you want to install open source software in it, but the vendor forbids it. So how do you do it? The same way. And of course, there are bounty programs. I heard they pay handsomely for remote code execution bugs. And of course, doing crimes. That's always on the table. I mentioned they run these boxes that you see on your networks or don't see. Hopefully you see them. They run different kinds of Linux, and you may think there are many different vendors that have many different operating systems, but essentially it's the same. So this basically is a snapshot of genealogy of an open source router operating system called OpenWRT. And what you see here are probably .dot, so I will explain. What originally was an open source project is now being actively forked and somewhat reshaped by many proprietary vendors like TP-Link, Zixel, Teltonika, D-Link. So what they do, they take a snapshot of that operating system, they do some modifications on top, they close source it, and they sell it as their own. And in some cases, they even have a fork of a fork. So that Teltonika RootOS, which was derived from OpenWRT, gave birth to the operating systems used by Unitronics and MDEX. So essentially, you see this proliferation of one open source project into all these proprietary systems. Why is it important? Because it actually creates problems. Recently, or not so recently, a generation of Wi-Fi 6 routers had to switch to the Broadcom system on a chip in order to support the new features. Unfortunately, OpenWRT doesn't support the proprietary drivers for that chip because they never had an agreement in place to do that. So the only way is to basically ship a closed source firmware blob as a driver within this open source operating system. And for OpenWRT, they simply decided not to do it. So there's no support for that. So vendors have to find a workaround by creating their own forks. And there was also a very nice presentation 10 years ago by Simon Wunderlich about the new FCC, and that is the Federal Communication Commission of the US. So they basically initiated a regulation which required the firmware vendors to lock down their firmware to prevent users to tinker with some non-compliant parameters like the Wi-Fi frequency and whatnot. And they especially forbade these vendors to make it possible to install a custom firmware such as OpenWRT. So for that reason, it was locked down in the US, and because US is a large market and its economy of scale, I think it was basically affecting the rest of the world too. I'm not saying these are the actual reasons why the vendors are doing this, but I'm suggesting that as a possible explanation. Right, and this firmware lockdown is not actually a good idea from many reasons, because many of the devices that you see on the market now, they're actually designed around OpenWRT, so it will not likely go away even in the next years, but what you have different kinds of snapshots that they create and freeze with custom coding on top. And those snapshots have various degrees of freshness because it's very hard to patch a firmware blob. It's very easy to patch a certain component when you have an open system. But for a firmware blob, you have to adhere to the release cycle, you have to test things properly, so it's a very long process. So vulnerabilities, especially in third-party software, they tend to accumulate. And of course, because of the stuff that I already mentioned, these proprietary derivatives of open system are unlikely to provide root. So we now end up in a situation when you buy a box, but you cannot modify anything inside, despite the fact that you own it. So there is another consequence that I want to draw your attention to, is that this kind of situation also leads to the fact that the users have hard time to inspecting the firmware or the software inside, and it makes it also harder for the vulnerability researcher to get inside and to see how things are. So vendors might try to get away with long release cycles and some things that are overdue patching. So if you want to actually look what's inside of your router or somebody else's router, hypothetically speaking, you have to begin somewhere. And there are several ways. I'm not considering here hardware hacking or covert channels or anything like that, because actually things are way more simple than that in most cases. So what you can do, actually, you can read the documentation or use guides or forums, because there is a good chance that somebody has already done that, but they never published it for a wider audience. So that's the first thing to do. Then, because I mentioned these are complex systems with lots of open source components, there might be some historical vulnerabilities that you may want to consider that are still unpatched. And those you can use to actually try to root the device. And of course, there is such thing as recurring vulnerabilities, which means that the vendor, or let's say the maintainer of certain projects, make the same mistakes. So you can basically try to see if maybe they forgot to fix something that you can easily find. Of course, the hardest thing is finding a new vulnerability and popping the root shell, which everybody seems to do, but it's the hardest of them all, except the hardware hacking that I already mentioned. And in terms of the functionality or points of interest in the implementation, you want to see if there's any technical support feature that looks like backdoor. If it's walk like a duck, it's probably a duck, but we'll go with technical support feature, and I will show some examples later. There are also things like software composition, which I mean the vulnerable third-party components that you can always rely on. And of course, things that are most likely exposed online is the administrator panels, web UIs, and whatnot. And specific attention should be paid to things that basically translate setting from the user LAN into the device itself. So basically the pipelines between the admin panel and the configuration files on the device. So here is the first example of the device we did a couple of years ago. It's a Sierra Wireless LX60, I believe. You can see it on the picture. It's a rack device that takes a SIM card in, and it's used as a network gateway in places where you don't have any traditional network connectivity. One of the use cases is some of the police vehicles, also field hospitals and things like that. So it's not a device you can find at your home, but from the inside it looks very much the same. And what they had actually on their website, and here I have to mention, it doesn't allow you to SSH into it or have any admin access despite the web admin panel. On the website, they have a guide that says, if you have troubles with your device, you can enable what they call a diagnostic shell. And then you call the technical support, you give them basically access, and they can fix the problem for you. What it actually means is that when you click that button, enabling diagnostic shell, it will write the hard-coded root password into etc password file, so that there's basically a hash of it. And if you have enough computational power, you can crack it and then basically gain access to any of those devices, because that's not the only one device that has this feature, but they practically use it elsewhere. We did not do it this way because it was a fairly complex password and we were just beginning, so we were wondering if we could do something else in this case. And here I'm coming to the topic of the vulnerable third-party components. That's a big thing because I want to give you an example of the study we did a few years ago when we looked at the TCP/IP stack implementations for embedded devices. And this is essentially a component that implements the whole thing from the Ethernet communication up to the application layer. And turns out there's about 13 or 15 open source implementation, and as many of them also are implemented by companies and are closed source, but probably there are many more. And the thing is that we analyzed about 20 of them, and we found 100 vulnerabilities, and many of them were critical. And they were there for many, many, many years. So if you look at the trickle down of this bug, let's just think about it. Let's take one vendor, let's say Siemens. They had NOT-EX, I think it was called, the TCP/IP stack. So what they did, they implemented the TCP/IP stack. They put it to a certain operating system running certain PLCs or medical devices. And then they decided, okay, it's a good, successful product. Let's sell it to other companies so we can white license it and they can also use it in their products. And what you can see, basically, then goes exponential. It can be a network management card or any other component used in other hardware or a different device itself. So basically, one single bug can affect not only multiple devices, but multiple vendors. So this is why, for the impact, we also look for these kind of issues. And this is why third-party components are the first thing that we looked at when we search for exploitable issues. This is an example from another study we did specifically on 5 router operating system, 4 of which were direct derivatives of OpenWRT. And this was the several snapshots we took. So this was the latest version of each of them. And we used certain tools to try to understand how outdated the open source components are, what are the potential historical vulnerabilities, and what is the risk involved in that. And as you can see, in all of them, except maybe Tonica, it was quite a lot. But all we know, it takes just one vulnerability to pawn a device. So this all represents risk and basically reinforces the point I made about the closed clones of the OpenWRT. Back to Sierra Wireless. So here we took the approach of looking at third-party components. However, the finding that I had at this point was a bit unexpected. Normally, you would find some known vulnerability or some component that is known to be bad, and you try to exploit it. However, if you see a component that is quite mature, is used in a lot of places, but doesn't have any vulnerabilities on the NVD or any other sources, this is where you have to pay even more attention. We had found that Sierra Wireless is using OpenNDS, which is an open source component used for setting up captive portals. So basically, in this hotel, you have one. You connect to the free network, gives you a pop-up, you insert a fake email address, you insert a fake one, and then basically lets you through to the internet. This is exactly what it is. And also, it's interesting to note that this component is a standard package of OpenWRT. So basically, they just carry it over. Unfortunately, the version was a little bit older than the upstream, but whatever we found there, it was 14 bugs. They were all affecting all the versions from the version 1 until the version 10, I believe. And in this particular case, it was a very interesting vulnerability in which you just interact with the captive portal itself, so it acts as a web server, and basically you can set the web request, and part of the web request is a query string. I will not explain what it is, I hope, because you are at the technical session, you know, but if you have questions later, I will be happy to do it. So basically on the top, you can see an example of that request, just querying the root page, sending a query string, and it works. The problem here is that it's defined to be finite, and it's allocated on this stack here. And basically, if you send a query string longer than this amount of characters, it's a classical Stack Overflow. The trouble here is that they didn't even parse it correctly. So in order to exploit this vulnerability, we have to work around other bugs within the code, which was a little bit interesting. But yeah, again, if you're interested in that, you can ask me later. But what it essentially means is that it was a very simple bug with very bad consequences for the whole system. So essentially, I will spare you the details. To bypass some binary protection, we had to use very simple return-oriented programming chain. And essentially, we turned this benign request into this simple command with some shell code in between that basically gave us a root shell. And because this project actually requires tools like ifconfig or other things to manage and segment the virtual network, it runs as root. So it doesn't require any elevation of privileges, and this is how we rooted it, basically. And this gave us insight into the inner working of the device, so we could do more research. The second example is drastically different from the first one. So this device is this big. It looks actually like a server rack rather than a networking device, and it's very powerful in terms of computation. And this is another example of what I was saying earlier. This is more about recurring vulnerability. So before we even started, we looked at vulnerability reports, and we found a very interesting pattern. They had quite a lot of OS command injection and stack buffer overflow vulnerabilities. So the first one are marked in red here. The other ones are in green, so you can distinguish. And it was practically the same functionality, the same bugs all over again. So we thought, OK, from our experience, vendors rarely do any kind of variant or root cause analysis. So whatever you report to them, they all just fix that and move on. So we thought maybe there is a chance that they have missed something and we can find something similar to this. And before I actually explain what we did, I just want to give a little bit more of a context. Because usually when you think about networking devices and some kind of embedded Linux, you have basically stuff that runs on bare metal. You have some Linux binaries, some Linux protocol stacks, and you have the custom binaries they add on top. And this all works as an ecosystem. In this particular one, and that was the first, this actually has the entire operating system virtualized. So it runs in a QEMU inside of the Ubuntu box. And the Ubuntu box is basically the real operating system. And there are some other binaries that basically manage that operating system, but it's completely closed, it's virtualized. And the thing with these stack buffer overflows, most of them were not exploitable, so usually it leads to a denial of service, but with this kind of design, even if it crashes, it resumes in about 2 seconds. You don't even notice it, so it seems to be very resilient and effective design. What we found, if we found another stack buffer overflow within this virtualized operating system, which was pretty exploitable, but it didn't give you any root, because to get the root, you have to escape this sandbox, which usually requires some kernel-level exploits and black magic. And then we decided to look how this virtualization was designed. So usually, this operating system that is virtualized, it has to talk somehow to the main operating system. And it happens to do that through the virtual serial interface. So basically, it sends some commands to the host saying, oh, I need a reboot, or I need my time updated, or I need other things. Of course, that's dangerous if you can send any arbitrary commands. But for that reason, they basically had a whitelist of commands. So there were only 10 of them that you can run. For example, this set Linux time is a member of that whitelist, and that's the only thing you can do. If you look at how it actually is executed, you may get some hints about what I'm about to show you next. And when we looked at the binary that actually implements the whitelist and the running, you will immediately see that here, this is all the unfiltered input, and this is where it ends up. So can you guess what is the problem here? Yes, but this one in particular, because what you can do here is that you can use that first vulnerability, stack buffer overflow, to contact this binary saying, oh, I need my Linux time updated. And then at the end, you can say whatever else you want executed after that as a bonus. And basically, this simple stack overflow here and this little bit of design decision allowed to basically escape that sandbox and get root on that Ubuntu operating system. So no kernel exploits were burned in the process. Finally, I would like to introduce our today target, because this was all the old stuff, interesting examples, but you want to see something new. And this time is a vendor called TP-Link. I don't know if you heard about the previous one, but this one probably is even more obscure, right? So this particular one is a device from the family called Omada, and it's based on MediaTek SoC with some Ethernet ports. It doesn't have any Wi-Fi, but it has a different use case. And in the past, in the recent past, it used to support OpenWRT in a way that, of course, it was designed for it. And on the OpenWRT wiki page, you could find a guideline of routing the device if you want to install OpenWRT on it. It led you to a GitHub repository that explained basically all you have to do is you have to SSH into it. You have a CLI where there's an undocumented command called debug. You type it in. It will ask you for a password, which is derived from the MAC address of the device and your username. And basically, you insert that, and then you get root as in the normal operating system. And then you can flush whatever you want. Last year, I saw there were some troubles in the discussion of that GitHub repository, and people were saying, oh, this tool doesn't work anymore. I cannot access the root anymore. What happened? And people were saying, yeah, probably they have changed something. I cannot even roll down the update. I cannot update the old version, so this doesn't work. What should we do? And turns out is that just a few months before, Cisco Talos found this backdoor, and they decided this is a serious vulnerability. They reported it to the TP-Link, got a shiny new CVE, and it was essentially fixed. And basically, you don't have any ability to root your device anymore. So we decided to have a look how it was actually fixed, and it was pretty interesting because now, so that you see the prompt at the top of the slide, now it requires you to basically sign a random string that they send you with a certain private key that you don't have. And then basically, if you should have it, then it will let you in. So they added some fancy crypto to it. But if you look at the actual implementation, I spare the details, but I put the right condition in here. If you have a certain file called image type debug present on the file system, the old way still works. So you can still log in using that password derived from just the MAC address and the username. Now, why they did that, I don't know, probably because they needed this for some kind of testing. But the problem was we could not use this path anymore for rooting the device because we didn't have the private key, and this file system doesn't exist. This file doesn't exist on the stock file system. So that was a problem. Upon looking at the code closely, I realized that the public key that they use to verify your signature is actually hard-coded. And it's the same public key used to now sign the firmware. So if it's a hypothetical situation, if a certain government has this key, it means they have access to all of your devices that basically run this firmware or some of the components derived of this firmware. No conjectures, just an observation. So it was still quite interesting to see if we can use some of this existing functionality to get in. And we could try to downgrade the firmware. The problem was we had to buy an old device. We had to do some tricks. And our goal was to analyze the new firmware anyway. So what I thought about that we need some kind of command execution just to help to create us these files so we can just use the old technical support feature to enter. And basically, for that reason, we had to find another target, look around the firmware, and see what will stick. And this is the actual target that we found. It's called Lucy. It's an integral part of OpenWRT. It's a very popular project used to configure embedded devices. It's basically a web interface with some scripts that translates changes you make through the web interface to the device configuration files. It's implemented using the Lua language, and yeah, it's really cool because it splits the interface logical parts into models and views, and basically allows you to do a lot of things without writing a lot of code. Specifically, why we chose it is because, again, if you look at the TP-Link's implementation of Lucy, you would see that in 2023 there was an issue with it that allowed to a lot of botnet creators, specifically Mirai, to hijack many of these devices. And this is an example of a proof of concept, which is just a post request that you have to send, adding some shell command in one of the form parameters, and you're good to go. And because it runs as a root, it's very easy. Later the same year, Cisco Talos has found, I believe it's 8 vulnerabilities of the same kind in the same component. Looks very similar. So we decided, hey, we see something familiar here, let's try it as well. What you have to know about Lucy is that Lua scripts can be shipped as scripts, so you can read them as human readable code. However, you can also compile them into bytecode, and this is for a performance reason. They say also for a compatibility reason, and so that users cannot modify important settings. Anyway, so this is how it's shipped in Lucy. And normally you can, there are plenty of tools that, because there's a lot of metadata, rich headers and stuff, you can revert it pretty easily to the human readable code with the off-the-shelf tools. When we tried to do that with the TP-Link implementation, we got lots of errors and essentially nowhere, because it was telling us it's invalid bytecode, there's some junk in the header, so yeah, go figure. And at the same time, it runs very fine on the router itself, so we thought that there is some black magic with the Lua itself, or maybe they have modified the virtual machine or the parser or something like that. We didn't spend a lot of time seeing how they did it, but we at least could identify what they did. And for that, very quick and short introduction to Lua bytecode. If you want to know more, at the bottom of the screen is a very nice paper, so I encourage you to read it if you're interested. But essentially, there's a main header with the usual magic that you see in the binary files. Then there is a version which happens to be the same that TP-Link uses, and based on that version, you have different formats of the header. You have things like NDNS and then various sizes of different types you can find in the Lua file itself, including the number and the way this number should be interpreted. It's called the integral flag. So if it's 0, it's a floating point. If it's 1, it's an integer. And here I will show some examples. There are also things like function chunks. So each function defined in a file has its own header with its name, other things, and at the end of that header, you can see a constant list. So every constant defined in a function will be found here in a certain format. For example, this is a string constant where it starts with the number 4 always, and then you have the next number of bytes tells you what is the size of this string. And this actual number of bytes is dictated there in the header, so it's the size of an integer type. And after that, you have the actual value of constant terminated by 0. This is the easy one. The hard one is the number constant, because there are 2 bytes in the header that tells you how exactly it should be stored and interpreted. The 11th byte, in this case, it's 8, tells me that in this file, the numeric constants have 8, the size of 8. And the last, the 12th byte here is basically tells me if it should be interpreted as a floating point or an integer. And here on the left side, you can see an example of the same number encoded in a different way according to that header. And basically, you see there are multiple ways of interpret things, and very easy to confuse the parser this way. So when we looked at how they actually have their bytecode and compared to the stock Lua, we immediately found that there are some irregularities. For example, they say, so on the left there is a header, they say that the integer is 8, while we couldn't find any integer of this size. And there is this very weird value for the integral flag. It's not mentioned in any specification. Moreover, things that looked like integer constants were designated by this number 9, which again is not present anywhere. So we decided, okay, let's try to fix it. And we did according to specification, and it worked. So I don't know why they did that, maybe to prevent reverse engineering, but as you can see, it doesn't quite do it. And finally, we could interpret the numbers correctly. So then, going back to the vulnerabilities I was talking about, we looked at what Cisco Talos did and how they patched this thing. And as with one of the previous examples, no root cause analysis was done, so we found one vulnerability that they have missed. And this one is concerning the field of the WireGuard VPN setting when you have to specify the private key. This is how it looks like. So the user input here is on the line 211, and it's passing through the function called save special string, which don't believe what it tells you. So as you can see, it's simply concatenated with the OS command, and then it gets executed in some way. So the problem here is that the function itself wraps the input into the double, how it's called, double quotes, but the input is already wrapped into the double quotes. So that's the first problem. And in this way, you could escape this thing and create another command. Moreover, they did not escape the new line character. So basically, you can see here how the normal input will look like, and it will be accepted by bash. It will work as intended. But if I just change it slightly like this, adding a new line and a certain point, that call at line 216, IOP open, and interprets every new line as a separate command. So it basically takes an array of commands. And it will just execute whatever I put in after the new line. So basically, all I had to do is just to run this command to create that file or get a reverse shell or whatever, and it worked. So here are a few things about TP-Link's response. Surprisingly, they assigned CVEs to these things, and actually, I see that one is pretty high. The thing is that this was just something we were beginning with, and we reported other things to them, which unfortunately I cannot talk about because they will be only fixed in April 2026, I believe. That's the earliest date. But yeah. And the thing is, like I said, software gets reused a lot. So this is an excerpt from their advisory. So all of these devices are affected by these two CVEs. Essentially, if you have one of these and you don't like the custom firmware, now you know what to do. I think the list should be longer, but I don't quite remember how many devices we estimated to be affected by this, but it's a lot. Yeah, and finally, just a little bit of demo. I will explain what happens here. So here I'm connected to the device. I'm SSHing into it. And here I'm showing you help. So as you can see, it's a limited shell with some things. And now I'm trying to put that debug command, and it tells me, no, you have to prove me with the signature that it is. Now I'm using one of the proprietary protocols that we reverse engineered after this to actually turn that OS command execution that was authenticated, I forgot to mention the one, into an unauthenticated one. And basically what I'm doing here, I'm simply creating that image type debug file just asking nicely, please let me have the root. And it generates the password for me based on the username and the MAC address. And now I can try to do the same. And it would work because it's a video, but just to demonstrate. So now you see the prompt is different. And I find it very ironic that this banner is still present here. But yeah. So it's the end of my presentation. Thank you for bearing so far. Just a few things I wanted to mention before I conclude. There's always a way to root down the lockdown system. So vendor makes it difficult for users, for vulnerability researchers, but eventually one finds a way, and one doesn't need to have any hardware hacking skills or have solder at their disposal. We could have soldered a UART interface to this thing, but I just don't like to do that. So it's much easier to do it with just plain software vulnerabilities. Of course, study what other people did. So if that's your daily job, you can actually save yourself a lot of time. And finally, locking down OpenWRT, I think it's a bad idea and will only introduce more security issues because you also have a lot of custom coding on top that is not tested the same way. That's it. Thank you very much.
All right, thank you. I will open up the questions if there are any questions here from the audience. There's a gentleman right in the front. The microphone is already running towards you. Wait, it's incoming.
Hi. Thanks for your speech and making our routers less vulnerable. I assume you have heard about local network vendor MikroTik. Did you have a chance to play with it? And if no, why?
Very simple answer. It's on the list.
Thanks.
All right, from my side, the question is, in one of the examples you showed that you would craft an HTTP header and a request which requires a particular offset as well, so you need to know when to override the return pointer. I mean, you mentioned that go dynamic, you do dynamic analysis. How would you identify this buffer size to override? Do you do static analysis of the frames? How do you approach this?
Yeah, one thing that I didn't mention, but there was a presentation yesterday about reverse engineering. You first emulate things as much as you can, but in the end you want to run it on the real device because this address will be different. There are other things in play that you cannot emulate if it's a more complex system, but essentially first what I had to do, I had to use the emulator to test the proof of concept, and then when I had to do it with the real device, I had to actually find an information leak that will tell me the address of the heap. And because it's an ARM32 system and it had ASLR enabled, on these systems ASLR is very inefficient in the sense that you can only have 2 base addresses for heap. One is more often than the other. So basically, once you know the base address, in 66% of cases it's going to be the same. So it's basically one of the 2 possibilities. You calculate the offset to that buffer with that base address, and that's it. But you need to have information leak or some way to peek into the memory.
Right, for countering ASLR, you need the info leak or on the other way. Any more questions? All right, I will try to merge my question with one of the questions that's been provided to us over Menti. During your analysis of firmware, especially the routers that are from China manufactured, do you encounter some backdoors and some nasty stuff that's there and like undocumented functionality, or you just, oh wow, this shouldn't be there, besides any other vulnerabilities, right?
This was the example of those things.
Okay. All right, with this, I thank you so much for your talk. Let's give a round of applause.
Thank you so much. Thank you.
Very, very good.
Thank you.
And we are transitioning from routing the routers into a way how to disclose the vulnerabilities and do the coordinated the vulnerability disclosure and bug bounty. So welcome on stage Eva Safranu from Mattermost, where she leads the product security and security research team. And well, if you're part of the CERT network or or you are using communications as an open source software, well, you most likely have been using Mattermost, right? So this is one what we use at the National CERT. I know that other CCERTs use as well. So please, Eva, the stage is yours.
Thank you. So, hello everyone. Thank you for taking the time to be here today. We'll be spending the next 40 minutes discussing everything from report to disclosure. So we just heard the first part, all the great things that researchers do, but the question is, once we receive those reports, how do we handle them? Before we get started, very briefly, I lead the product security and release engineering teams at Mattermost, and I was previously at Okta as a principal product security engineer. It is important to briefly mention what Mattermost is because this influences how we've designed our vulnerability management program. Mattermost is a secure collaboration platform, and it is for mission-critical work. So our audiences are mission-critical operations, defense, and DevSecOps. So from this, you can understand that our audience, they have high security standards, stringent security requirements, and we need to take this into account when designing a vulnerability management program. Mattermost is also built as an open core platform. This means that the vast majority of our code is open source. And while open source code has great benefits when we talk about the fact that the code can be audited by anyone, it does have some challenges when we're talking about vulnerability management. So in a very high level, what are the different stages of vulnerability management? It should be like pretty obvious to most of us here. We have an intake, we triage the report, we start fixing it, we release the fix, and finally, there is a disclosure part. This should be similar in most organizations, maybe with the exception of the disclosure. This is something that closed source environments don't do. But when you think of open source or open core, you need to tell your audience of vulnerabilities so that they can upgrade. And there is something more that Mattermost is also offered as a self-hosted instance, which means that customers who run Mattermost in their environments, they also need to know if a new release that comes out contains vulnerability fixes or not. It is also important to be clear when designing the program on what are the responsibilities and how they're split. And usually, security takes care of the two ends of the process, so intake, triage, and finally the disclosure. Engineering usually works on the fix and the fix release. We will cover each of those phases separately, but before we do that, we need to think of what a good vulnerability management program looks like. And this will drive what kind of metrics we want to have. The way I usually approach this is by finding what kind of questions I would like to be able to answer. What's the severity of our vulnerabilities? So the trend we want to see is less highs and criticals and more lows and mediums. So we should have a metric saying that over time, the percentage of highs and criticals gets decreased. How many vulnerabilities are we resolving every month, and how many are introduced every month? If you combine those two questions together, what you want to answer is, are we trending towards an ever-increasing amount of open vulnerabilities, or are we trending towards zero? Like, if vulnerabilities keep increasing, we need to take some sort of action. What types of vulnerabilities affect us the most? If we have access control and authorization issues being our top one, we should take some action there. It can be additional training for our engineering teams. It can be using our static analysis tool to write some custom rules specific for how we design authorization internally to catch those better. It can even be a policy saying that if you're touching endpoints and like touching permissions, you need to let the security team know to review. Are we hitting our SLAs? There is no vulnerability management program without SLAs, and there are no true SLAs if we don't measure them. And again, the trajectory is that the SLA hit percentage is getting higher. There will be times, though, where SLAs are not met. And to answer the why and how we can improve, we need to know in which stage of the process the vulnerability takes the most time. So did we spend too much time in triage? Was it in fix? Or where was it? So some data there will be helpful. Let's start with the report intake. There are usually two important things that you need to know. One is know where to expect vulnerabilities to come from. Like, it can be from bug bounty programs, public or private. It can be from a VDP. Usually both of them are handled by a third-party vendor. The difference is that VDPs don't pay out researchers. It can be a customer of yours. It can be internal, like your engineering teams. It can be an email. Usually organizations have a security email or a responsible disclosure email that we also need to monitor. It can be your annual or semi-annual pen test. Whatever the list is, it needs to be clear and it needs to be monitored. And the question is, by whom? And when I say whom, I mean a specific person. Every time the responsibility is a group responsibility, I'm not sure there's real responsibility there. So 2 options. You can have a dedicated person. It's always the same person making sure that new reports are getting handled. Or it can be a triage rotation. And the latter is what we do at Mattermost. We have weekly rotations. So each week we have a specific person responsible for handling that. And because we don't want to remember when is my time, we actually use PagerDuty. We have a triage calendar there, and we get notified when each one's triage starts and ends. If we go to the triage phase, first of all, we need to reproduce behavior. And one of the things we need to do there is identify if we have any specific configuration that is required. I'm very purposefully using the word behavior and not vulnerability. Vulnerability is a statement that we need to assess whether it is or not. So for now, we just need to make sure, is what the reporter is saying reproducible for us as well? And then we need to answer the question, is it a vulnerability or not? And to answer that question, I will not comment on the false positive because this is pretty easy to tell, but there are some additional questions to answer. Is this a vulnerability or a security enhancement suggestion? And I'll try to explain how I differentiate those two. If you have a statement saying there is a CSRF vulnerability in that endpoint that allows me to do X, Y, Z, this is a vulnerability. It is exploitable in the system today. If you get a report that says that a user can perform sensitive operations without step-up authentication, so without requiring authentication, I will most likely classify this as a security enhancement. Every software can become better in terms of the security within the product, but the reason I want to differentiate them and be very strict on what I classify as vulnerability is because I want to have a very strict vulnerability management program. It is one where we partner with our engineering partners to make sure that vulnerabilities take priority over other work, and to do that, they also need to understand the importance of it. If we start sneaking in like security enhancement, I think we start losing the trust that we need and want to build with everyone we're partnering with during the vulnerability management process. The other question is, was this a design decision of the past that we now view as insecure? And what I mean by that, it's possible that 5 years ago, we designed a feature in such a way that we viewed as secure. Threat landscape changes, the risk appetite of an organization changes. So the fact that we decided like that before means nothing. And we can handle this as a vulnerability too. So we can have code implementation misses or deliberate designs that are now viewed as not secure. And finally, we need to do some root cause analysis. We've found it recently very useful to use AI tools for that. So if you give the vulnerability report and then the source code, it is usually quite easy for AI tools to pinpoint where the vulnerability is and walk you through the whole attack flow. Again, you need to check your AI policy in your organization to see if this is allowed for you or not. So once we've done that, we can start to kick off the vulnerability management process. There's usually some sort of a ticket creation. We have reproduction steps so that engineering teams and our security teams too can reproduce it too. Some suggested mitigation that comes out of our root cause analysis. Severity or risk, and this will influence our SLAs. And finally, we need to collect some data to drive our vulnerability management metrics. Now, you see here saying both severity and risk, and I want to discuss a bit which one to measure and when. Severity measures the impact without taking into account the environment in which the software runs. On the other side, risk is environment-specific, and it maps better to an organization's threat model. So I may have a vulnerability that is high, but there are compensating controls in the specific environment that lower the risk. There can also be a policy of an organization saying that internal services I consider them less risk. So the same vulnerability, if it moves to an internal system without internet access, then the risk is lowered. Now, in the open source environment, we don't know where our software runs. The code is out there for anyone to use, and this is why we need to measure severity in open source software, which is actually taking the worst case scenario of an environment with no compensating controls that just this software runs and nothing else. Let's go to vulnerability fix implementation. What are the risks in fixing vulnerabilities in open source repositories? And how could we possibly minimize those risks? I'll bring an example, and I'll read that for those at the back. Look at the title, restrict guests from reading public channel posts. Look at the description, it's even more detailed. It says that a guest user was able to read a public channel post from a channel they were not a member of from a specific endpoint, so this PR restricts those permissions. Even the commit says the same. This PR is perfectly fine if your repository is closed source. It gives all the details for your reviewers to go and review it perfectly. But if we think in open source, the moment you push a PR to fix a vulnerability, you've also disclosed everything. Does this look better? It does. We've updated the title, the description, the commit to be high level, like update guest permissions. We may be updating guest permissions because there's new feature being added, and we need to update permissions. It can also be a vulnerability fix. Are we safe? No. The code is still there. Like, anyone can go, check the code, and possibly identify what is the issue. It really depends on how complex is the issue. If it's 2 or 3 lines code, it is very easy for someone to understand what was the behavior before and why you possibly are fixing it. In more complex scenarios, then it may take more time, but still, the code fixing the vulnerability is public. So with that, it is important to always know that the time between a PR push, a fix push, and the final release, there is time where some amount of vulnerability details are disclosed. There is an alternative, which is we could be using private forks in GitHub. In this case, all the collaboration during the review phase happens in closed source, and then the final code becomes available after merge. Now, it's not that we saved all the time, but yes, we reduced the time, like the time between PR push and PR merge, now this happens in closed doors. Whether we go that route or not really depends on the organization, because private forks come with some operational burden, like creating the fork, inviting each one specifically, and so on. So it is a balance that it's up to each organization to decide whether to go that route or to. And finally, as security professionals, it is important to review that fix. I'll go back to what I said in the beginning about we've done the root cause analysis, we suggested some mitigation. Let's go back and check that they did it correctly. Engineering teams are not security professionals. And finally, let's include tests to prevent regressions. What we don't want is a month, a year further down the road, someone adds some new capabilities, and without realizing, they reintroduce the vulnerability. So having tests would catch this and would prevent regressions. If we go to disclosure, we need to give sufficient time for both customers and end users. We need to have time for them to upgrade before we release more details. And in order to be able to do that, we need to document the process and publicly. So we need to be transparent to vulnerability reporters who want to know when they will be credited for their work, when can they blog, when can they have a CV on their name. At the same time, we need to be transparent to our customers. How much time do I have to upgrade before vulnerabilities details are out there? What we do is that instead of fixing just on the next minor release, we also fix on all the supported versions, like with a patch upgrade. And this helps customers and users not have to have a minor upgrade, but just a patch one with a vulnerability fix that is usually more easily justifiable within different organizations. And we are a CNA for our own CVs, so we control reserving our CVs and publishing those. But another thing that we are doing is that we have a page called Security Updates, and we also disclose vulnerabilities there. It's pretty much the same details as in the CV file, which is what are the affected versions, what are the fixed versions, the severity, and then some details on the vulnerabilities. And what this offers is that end users and organizations can actually subscribe to those updates and get notified when there is a new release that contains vulnerability fixes, and so they know, well, we need to go and upgrade. We have 30 days between vulnerability fix and disclosure, so within those 30 days, organizations using Mattermost would need to go and upgrade. I want to spend some time demoing a bit our internal process, and I'll give specific focus on how we've tried to automate the process. The reason is that vulnerability management is a very, very repeatable process. It's also quite manual, and I don't want to say boring, but you do the same things all the time, and like if we can automate that's even better. So this is our Jira workflow, and the reason we've designed it this way is that it maps to the different phases of the process. And so it starts with, like, in reviews, when we're triaging the finding, you get to fix development, engineering is fixing it. After merge, we move to release preparation, and we're preparing the releases. The reason we have release preparation is we're not just a SaaS, we need to actually prepare the self-hosted versions. And then we move to the CV preparation, which is after release and before the disclosure. Now, what this allows us to do is that we can enforce phase transition requirements, and this is how we make sure that we collect all the data we need for our metrics. So before you move to the next stage, you cannot do that unless specific vulnerability data are filled. And you can also trigger automation once you transition to different phases so that different actions can take place. So I know this is small letters, I'll explain. The next 3 slides are videos that walk you through the process internally, and I'll be pausing and explaining. So this is a vulnerability that came to us a few years ago, and it is a zip bump. Mattermost has something where you can have Kanban boards within Mattermost, and to do that, you can create them within the platform, or you can also upload a new board. So we need to have an import functionality. And the vulnerability was that in that import functionality, there was a zip file, and we were not checking the size of the compressed files within the zip file, which could turn into a zip bump, and that could lead to a denial of service or a crash to the server. So what happens when we first, as you see, or you don't see because it's very small, at the top we have a description, then we have detailed steps on how to create a zip bump, how to upgrade, and on the mitigation, they recommended, in this case it is, and this is Golang specific, it's just use a limited reader so you don't read everything. So let me hit here the play, and what I want to show is that this is a vulnerability ticket, and we have a linked bug ticket. This is what our engineering teams will work on, and this is automated. The moment we create one, the same details are copied over to the bug ticket, and we have a new channel created internally in our Mattermost, in our internal Mattermost instance. Another thing is, Mattermost has something called playbooks, which are, you can define repeatable processes, is what you see here, and we document all the different steps that we need to take in different phases. So it's the trias, and I'll scroll down in a bit, and you see investigation for exploitation, remediation, the resolution. And this is a channel where we are inviting engineering to work on and collaborate. Because we're open source, we cannot have all the discussions in public, so we have per vulnerability channels and playbooks to ensure that we collaborate internally before we push out the PR. The next video is, we've moved forward, the engineering teams are working on the fix, and if you see here at the bottom, there are three fields. Security update text, this is what we would, sorry, that's the next video, I'm here. Yes, so these are placeholders, and if we go, and we have reserved the CV here already, but if you go to the back ticket, you will see that the ticket has the same disclosure details. What we're doing is that engineering teams are responsible to document the CV details. We will review them before the release, but they have all the context when they're working on the fix, and they are equipped to create the details. Now, what I wanted to show with this video is that there is automation where when the back ticket is moved from submitted to resolved, which means the PR is merged, we actually copy these fields and we paste them over to the vulnerability ticket. Now, why don't we just have them in one place? People don't want to change tickets. They just like their own ticket. They have their back ticket. This is what they're working on. They don't want to care about anything else. So this is why, like, you stay, engineer, and the engineer will stay on their ticket, and we'll handle, like, copying over whatever we need with automation. Another thing that happens is that we played this. Another thing that happens is that we have automation in place that notifies our release manager, and you'll see this briefly, that the fix is merged so that she can start working on the releases. And again, it's our favorite bot. People don't like being told what to do by humans, but they do like if it's a bot one. And moving to the final one, which is we are releasing everything. We have released our vulnerabilities, and we are ready to move to the CVE preparation. You see here there is some automation where affected self-hosted versions are automatically added based on the fixed versions. But what happens is that once we move a ticket from release preparation to CVE preparation, we have automation that collects all the data that is within this file and creates our final CVE file and attaches it to Jira. And you see here like the CVE file. So what this allows us to do is, we as a security team, we do nothing with disclosure before the day we need to do the disclosure and like review the details that engineer is put. Everything is automated, like we've filled the data, but we haven't gone ahead and created the JSON file. Another piece of automation, and again it goes back to people like bots that don't like humans, is automating SLA notifications. So we have a midpoint reminder and a final reminder 1 week prior to the due date. And what the automation does is we can map between the team responsible for the fix and their engineering manager, so we can notify them when like to have SLA reminders, both midpoint and like when the clock is ticking for the final due date. Closing. On addressing critical vulnerabilities, we still use the same process, but not exactly. And the reason is that critical vulnerabilities, being critical, they need some sort of urgency that a normal vulnerability process doesn't usually help with. So what we do is actually we treat critical vulnerabilities as incidents. I found that incidents is the most well-organized process that is acceptable by the whole organization to bring everyone together now and to sidestep things like, but I have this feature to work on. It's okay, this is an incident. And so we can bring everyone together if it is an incident. It's the only way we can have a fix in 24 hours or 48 hours and have the buy-in from the whole organization that this takes precedence. So it is good to have time zone coverage. This depends on your organization. We are global, so what we're actually doing is that when the business day ends, then we have a handover to the next time zone, and this allows us to sort of work around the clock during critical vulnerabilities. And we also need to get buy-in. As I said, I can start pulling in engineers and like stopping them from other work, but it is good that the leadership knows this beforehand. So we need to get buy-in for that. And we need to document expectations. Incidents and critical vulnerabilities can be stressful when we need to identify the root cause, fix, and notify customers in like 1 day or 2. So letting people know ahead of time what exactly they have to do during this time, it helps make the process smoother. The final thing I want to share before closing is that vulnerability management is a shared responsibility. It is often seen as something that the security team owns, the security team handles, and engineering or other organizations help. And I don't think this is the best way forward, and this is why throughout the process we've created, what we're trying to do is to elevate engineering as our equal partners in this process. We can triage vulnerabilities, we can assign whatever risks and data we want there, but if engineering is not there with us to work on the root cause, to work on fixing the vulnerability, then we don't really have much progress and much success. So what I would like to close with is, let's try to make vulnerability management a shared responsibility within our organizations so that everyone sees the value of coming together, working on fixing those vulnerabilities quickly and efficiently. Thank you.
Thank you, Eva. I will open up the questions from the audience. If there are any, just raise your hand and I'll try to notice you. Okay, there are no questions so far. I have a few. So we as a national CERT and also as a European Union, we are introducing all of those vulnerability disclosure platforms where we need to process this. In your experience, how much vulnerability trolling, like when you're overflowed with useless vulnerability reports, you have that in your cases as well? And also you mentioned, adding to this, you mentioned that you're using the LLM as well in that process as well to dissect, like if the report and the proof of concept actually makes sense. Does that allow you also to kind of limit this trolling of vulnerability reports?
That's a very good question. So we're lucky to be using vendors that handle the incoming reports. I think 95% of our incoming reports come through our bug bounty program, which means that the bug bounty vendor can handle that load and protect us from these vulnerabilities that come and are not true positives. Otherwise, there was a time before that we actually had to handle. Yes, it is cumbersome, but what I've seen is that it's the same behaviors marked as vulnerabilities and reported all the time. What we had done back then is that we actually had an inventory. This is what they're reporting. This is our answer why it's a false positive. So we were trying to make it easy to not just type the same response all over and over and have it ready there. That's the first question. And for your second question, I guess we don't use that. When we were treating vulnerabilities ourselves completely, AI was not where it is today, so we were not using it that way.
All right, I mean, I have a question about the timelines. So just the regular vulnerability resolution and the criticals, how long on an average would it take between the regular and the critical that you've assessed?
So our criticals have 2-day SLAs, 48 hours. And the reason is, I would actually like to have 24, if you ask me. But because we have self-hosted releases, there is some process around actually creating the final releases in all the supported versions that take some time. We also have a cloud offering, and we need to make sure that this is also patched together with our self-hosted releases. So this is 2 days. And then, yes, it depends on the severity. It's 15 for highs, and I think it goes to 30 for mediums and so on. We're trying to be strict. This is why I said earlier that I want to go through the vulnerability process only when something is really a real vulnerability, because we've managed to get buy-in for strict SLAs, and we need to be also mindful of what we add in that process.
Right, I will still look for the questions from the audience. So, now, okay, you were first. Let's go here with the gentleman in front row, and then we have one more question.
Hi, thanks for the talk. I'm not sure about internals of your product, but I believe you are using other third parties dependencies. Do you have a separate process when vulnerability stems from a third party?
I was actually expecting this question. We use almost the same process. So yes, we have the same process. There are a few differences there. There is no disclosure. The CV is already out there. It's not in our software. SLAs are a bit different, but not that much. So the main difference with third-party vulnerabilities is, are they exploitable in our software or not? And this is something that we have as a difference between the two processes, although they use the same Jira workflows and everything, which is there is a a consideration. Does it make sense for me to go and spend time at understanding if this third-party vulnerability is exploitable in my system, or is it simpler to just go and upgrade? If there is an upgrade, usually that's the fastest route, and we often don't go through the route of identifying exploitation or not. If there is no vulnerability fix, and there are a few different routes there. What we're trying to do is contact the contributor. There are many times when we've worked together with the maintainer to create the fix and have the release ready. Another thing is, how can we change our code base to protect against that vulnerability, regardless of whether and when the fix will be available. To go through that path, yes, this requires that we've concluded that it is exploitable in our system, but at a high level to your question, it is mostly the same process.
Thanks a lot for extended answer.
Thank you. And the next question over there.
Yes, my question is, when you are fixing these vulnerabilities, do you have some kind of dependencies between the functionality in Mattermost? For example, this file size, if it's some dependent on the other functionality, how you handle these changes? For example, in financial world, we have a change advisory board who can approve it, these dependencies, or is it something like in the Mattermost world that some, when you're fixing the vulnerabilities, is dependent from other functionalities internally, and how you are dealing with these dependencies between the functionalities?
So I think one part is that we're not a really big org, and this helps with internal communication and collaboration. There are times when changing something will affect something else. This is true. And I think this is where small organizations are more quick and to address that. There's no need for an advisor. We just go and ask those people. We let them know, and then we find a middle ground. What you're describing, I've seen this in larger orgs, but not in ours.
All right. We have time for quick questions as well, so if there's anyone else. All right, for me, the question is, because you do offer the free community edition, which is pretty much most likely the one most widely used out there, but you also have the paid commercial version. Do the SLAs vary between those, or you just keep everything under the same kind of release and patch cycle?
No, it's the same. It is the same, exactly the same release process. It's just during our release process, there's a team edition, the enterprise edition, but they happen at the same time.
All right, with this, let's thank Eva once again, unless there's a last-minute question. No, let's thank Eva once again. Thank you.
Thank you very much.
Thank you. With this, we go on a break, which is a bit longer than 1 hour for you. But with the rest of you who are watching us online, we will resume after 1 hour, a little bit more than 1 hour. In the meantime, enjoy the lunch break, talk with the vendors, and after the lunch break, at ALFA, here in this room, we will be talking about playing games and training in cyberspace. In Omega, which is our cyber stories, it's going to be operational technologies from Navy ships to civil military infrastructure and power grids. And in Beta, we will talk about from failure to success. Enjoy your break, talk to each other, and see you very, very soon here. Welcome everyone back. I hope you had a very good break. You had something to talk about and you're ready to learn a bit more. So we are now going on to the last session, which is going to focus on cyber exercises and CTFs, everything playing games in cyberspace, from serious games just for fun. And I want to welcome on stage the first speaker of this block, Dr. Youngjae Mang, who is my friend. We worked together at the CCDCOE. We met at Locked Shields. We were playing and hacking together operational technology devices. And he will be talking about the cloud-based live fire exercise called Apex. Welcome him on stage with a round of applause.
Good afternoon. I'm Youngjae Mang from South Korea. It's an honor to be here to share my experience about cyber exercise. So maybe you are curious about this background image. It's a chessboard, right? I think what I did on my experience was similar to this image make on cyber range, make on GameNet. So this could be a case study for those who are interested in building a new live fire cyber defense exercise. So live fire cyber defense exercise technically means there should be lots of network systems and services for blue teams to defend, for red teams to attack. Then who will build this system is a green team. So from the very beginning, green team is very busy on developing, deploying, operating, and monitoring everything so that this live fire goes on well. So this calendar is last year. South Korea had a new live fire cyber defense exercise, so-called Apex. And I became a green team, red team leader of this exercise in the middle of March. It was right after the partner one of Luxus. I just got to South Korea and became a green team leader of the exercise. And I'm heard that this exercise, Apex exercise, should be happening in the middle of September. It sounds like I have 6 months, but actually it's not, because there were 2 test runs were planned. The first test run was on July. That means 4 months. But what I'm planning was to build an infrastructure and a platform for the exercise. That means the core of the exercise. Then becomes a lot shorter. I will explain it later. So as soon as I become a green team leader, I was checking what resource I have. At the moment, no infra and no on-premise server was ready. And so that's why I had to use cloud. We used cloud for running live fire cyber defense exercise. That was the only option for me. And I heard the budget, how much budget we have, and heard that it was so limited. We cannot run a large fire exercise with that budget, but still we can run a small size live fire. And small team. At the very beginning, it was only me who was starting to make a plan and design this architecture of cyber defense exercise. And not enough time, I already mentioned this. So I'm going to build the live fire cyber defense exercise. It will be a cross-team exercise. So what I've heard is that we don't want to make competition. We want an exercise that different teams cooperate each other, sharing their information to find a vulnerability, to make some patch script. So we can provide them throughout the portal system. And there should be a compatibility with Luxus, because it was already planned to have some contents from Luxus, for example, web services and operation system. And then OT system power grid. So we have to consider the compatibility with the Luxus. And the long-term sustainability. What this means is that actually South Korea had live fire exercise before, several years back, from 2016 to 2019. There was an exercise so-called cyber conflict exercise. It was a live fire, but it couldn't keep going on because it was too heavy to maintain. So it became like a lecture for me, because I was a Green Team Red Team leader at the exercise as well. So this time, if I have a chance to make once more, then I wanted to make a very light one, thinking of very efficiency. So if you are making a CDX just for one time, maybe we can just focus on the vulnerabilities and the exploits. But this time, I just wanted to focus on the Green Team stuff, more likely core Green Team stuff, for longer sustainability. So from now on, I'm going to introduce what I did last year to make this new live fire exercise step by step. The first thing we did was we bought domain. So we bought the public domain, for example, something.net. It's used for using VPN access. It's the only service exposed to the outside. And we bought some private domains, for example, Selenoa, Nickelonia. For example, Selenoa is good guys, and Selenoa is in the opposite side. We use these domains in the GameNet. And we have to choose some collaboration channel, collaboration platform. For example, from the beginning, different teams need to make a meeting to decide anything related to cyber exercise. And maybe we can install open source ones, but as I said, we wanted to reduce any resources. So what we chose is the SharePoint and the Teams, so that we don't need to install by using our manpower. So using this Entra ID, we can manage users' accounts and share documents related to exercise. And you can do some communication throughout this platform. And I start to think what we should build. As I said at the beginning, it was only me who was planning and designing. Later, I got 3 more in-house developers, but definitely it could be not enough for building a live fire exercise. So my focus was to minimize required manpower to develop anything. So I was thinking, like, okay, let's make a list that is necessary for CDX. So we bought domain, we chose collaboration platform, and then infra. So as I said, we didn't have on-premise server at the moment. So we were searching cloud platforms, what cloud we are going to use. We chose Azure, simply because it has a better Windows support. We wanted to make a GameNet like this on Azure. So users will access to this GameNet using VPN. So VPN is the only service that is exposed to the internet. And when it's time to do some exercise, it's happening in the private network. And we started to dig into Azure, because at the moment, it was my first time to use this Azure cloud. So the first thing in the Azure I did was I decided naming convention. So when you make a VMware virtual machine, from the first thing is which team is this virtual machine is in, and the next thing is a subnetwork and the service name. So starting from this, in Azure, you can simply make a virtual network. It's so-called VNet. First, you make a VNet, make a virtual machine. It's easy. You can simply done by using Web UI or Azure CLI. And if you make another one, another VNet, and make a VM there, then basically they cannot communicate to each other. How can we do it? There's a network peering. In Azure network, if you make a different VNet, there's a button to connecting each other. It's so-called peering in Azure network. So I found a way to make a connection between different networks. And subnets. So my idea was that a single blue team will have a single VNet. And in this VNet, we'll have several subnets. For example, we want to have several subnets in blue team network. We doesn't want to have just a single network in blue team network. So we made it. But the problem was that the Azure network, all of the network communication is done by Azure. It's not done by my setting. I didn't set any routing, no. What I did was just setting IP address and make a network appearing, that's all. That means Microsoft Azure Cloud is controlling all the network communication, including routing. But in our case, it's a live file anyway, so we wanted to make our own custom routing. We wanted to put our custom routing and the firewall in the blue team's network. And I found this setting. For example, if you make a virtual machine, you can make a so-called UDR, user-defined routing. But this machine is the next hop. It's kind of setting of routing. So you can set the next hop IP address like this. But this hop address we cannot use from .1, .2, .3 because it's already reserved for Microsoft Azure use network. So we chose to .4 as our gateway IP address. And we make a VM that has .4 IP address. We used OPN Sense to handle this .4 IP address and route and dust the firewall for every traffic that's coming in and out through this router. And for the green team purpose, we made two networks. One is CNET, Simulated Internet, and the other one is MGMT, Management Network. Why we made these two is that, for example, in CNET, we wanted to make all the communication go through this firewall we made. But this management network, for example, doesn't have a route table. That means it will use Microsoft's one. That means even if there is a router turned off, for example, some problem happened, it still can approach access to the blue team's VM. That is good for management purpose, because if you want to build this kind of setting in the on-premise server, it's kind of tricky. But by nature, this Microsoft network, they provide this kind of setting. So it was a good thing to use Microsoft's Azure. So from now on, we just got to know, okay, I think it became possible to make a private network to build a cyber defense exercise. Then the remaining thing is that how can you make a platform for the exercise? As I said, we are not, as a core green teamer, we don't want to focus on the vulnerability and exploits. We wanted to build an exercise platform that is easy for the other green teamers to deploy VMs easily. So we used this collaboration platform as a single sign-on as well. because this entry ID, we can use this authentication for every single service we make. For example, inventory, Git, this portal system, snapshot management, all the web services we made, we used this entry ID authentication. It was not enough. So we also want to some kind of authorization. So we made a single sign-on server for the additional authorization. And other things I'm going to explain in later. Yes. So this is one of the concepts we had. We wanted to minimize what needs to memorize. This is important because as a core green teamer, for example, if we make different services that has different ID and passwords, what happens? What happens is that the other green teamers will give you some emails saying that, can you initialize my password? This is kind of interrupting if there's many green teams. Core green teamers, their daily work is to build this exercise. They are using all these services every day, so they are unlikely to forget their password. But the story is different for the volunteers because they don't use our system that much. So they initially set their password and just simply forget. Then when core green teamers are busy, if we receive this kind of emails, it's kind of interrupting. So we decided to use only single password when accessing our live fire exercise environment. And the VPN profile doesn't require any password. It's just a file-based one. We use the OpenVPN. So when we invite the users, then we send their account and password entry ID and this file, VPN profile. Still, he doesn't need to memorize many things, just one password. And even though we did this, sometimes these users erase the email and forget this VPN profile. So what we made is some kind of this welcome page. This is also exposed to the internet. So user access to this site using entry ID. Then once he accesses this welcome page, then he can download this VPN profile again, so that these green teamers can focus on their main task. And the next thing we did was just simply install the Git. We set all the scripts in Git. And we used this Git as a wiki and the inventory because we wanted to have all the VMs listed in this Git. And it's needed, this Git is needed because we are going to make a deployment system. So all the scripts from Git we are going to maintain. So here's the deployment system. As we are using Azure Cloud, we can simply use Azure CLI and invoke a script to set up services and set up vulnerabilities. And what we did was that, as I said, initially we used the Git as the inventory as well, but it was not enough. So I made just a single web page, just one page-based inventory that has all this information: network, VM name, role for the Ansible, and the full name that I explained already, and VM status, IP address, FQDN, OS, and so on. So all the required information for deployment should be there. And then for the deployment, we need also certificate. Remember, we bought some domains. And when we are deploying web services, we need to have a certificate. We are using free certificate services, but problem is that if you are making many queries, there's a limit. So we have to make a cache service to download these certificates. And one other service we made is that snapshot management. In Azure Cloud, it's possible to make a snapshot and restore from this snapshot. But the difference from VMware is that in VMware, you can make a snapshot memory as well. But in Azure Cloud, it makes a snapshot only the disk. So it was important that when you make a snapshot, you have to turn off the VM before you make a snapshot. And inventory, Git, certificate, snapshot, all these are connected to this deployment system. It's based on Ansible. We chose Ansible because, as I told you, we wanted to have some kind of compatibility that with Luxus. So Luxus is using Ansible, so we also chose to use Ansible because we wanted to reuse some codes there. It's 100% compatible, but still, many of the codes are reusable. And if you see this image, there's some icons there, the green light. It says the VM running. It was important for us that if you are deploying the same setting for all different teams, when it comes to like troubleshooting, we wanted to know whether it's a network problem or even VM is powered on or not. We wanted to check. So we made a simple Azure CLI comment to check if this VM is turned on or not. For example, at the moment, we had 8 number of blue teams and two teams for testing purpose. For example, we chose 51 for the green team purpose and the 52 for the red team purpose, red team testing purpose. So far, I've been checking the list I made, and rest of is that the portal and the available checklist remained. It was kind of like a tough decision to decide whether we are going to develop this portal or not. Maybe we can simply choose to use open source ones. For example, CTFD. We can like modify the CTFD to use as a portal system. But we found that we need more services that doesn't provide CTFD does. For example, we wanted to have credentials for the blue team systems, and it has also forensics. This one CTFD can cover, but still we wanted to have reports for the non-technical part teams. For example, there will be inject, and we wanted to score this inject, and it's not just one time used. If there's a scored one, they just want to review once again. This should be happen. This kind of function we could not find from the CTFD. And yes, the ticketing. We also implemented the ticketing inside this portal system. And the rebirth. Based on the snapshot we made, blue teams can just make us revert their snapshot based from this portal system. So there were more functions from this portal system, so we just decided to make our own portal system. It's a kind of single entry point. After getting to GameNet, what users are facing is just portal. Then from this portal, users can visit every single service we made. And after that, maybe you need some kind of monitoring for operating this CDX. For example, if you have your on-premise server, then you might want to monitor how many percentage of CPU is used, and RAM and disk as well. But in our case, we didn't have to use this kind of service because we are using Azure service. They're doing their work well. So it's like unlimited resource for us. So we didn't have to monitor the physical server resources. The next one, I already explained, we wanted to check whether the VMware is turned on or off. And next thing is that I made for the Luxus. This is different because it also checks the network is reachable or not. For example, even there's a service, this availability checker is checking from different source IP addresses. This check also shows you the make a visualization so that when it comes to when it's time for the main execution, just before main execution, you want to make all green so that blue teams can do their work. But if the number of services are too many, it is not easy to check or make all green. So this kind of visualization will help for green teams to do some kind of fast troubleshooting. And this is what I made for the Apex. It's a visualization of availability check. I just wanted to show the first one. This one is a last year's one, first iteration of Apex. We had the power grid. It's easy to read because green means OK, red means not OK. So every blue team had the 15 number of web services and power grid as an OT system. What this system does is that it has hundreds of headless web browser. Through the proxy, it accesses to the target web service. It makes a screenshot and does some resize of the image so that after this browser make a screenshot and the resize of the image to the smaller size, and it sends it to the OCR. I use the Tesseract. Why we use it? We wanted to automate checking whether the site is defaced or not. In this way, we didn't have to invite the user simulation team. We just wanted to automate these kind of functions. And this availability checking is only showing its index page, but in the background, it is visiting all the different URLs it has, URIs. For example, if it has a login function, it tries to log in. If it has, for example, file upload function, we are checking this file upload function, and also the download, so that we wanted to check the functionality as well. For the average checking, we differentiated the IP address because we are using A-class network. We can have tons of IP address. In this way, from the blue team's SIEM or SOAR network services, we wanted to look like a real environment. For example, if there's this kind of traffic generation, what happens is that there will be only red team traffic. Then it is different from reality. Blue teams tries to just block everything from red team's IP address. So it is very important to hide the IP address that red teams are using. That means we need more number of IP address for normal traffic generation. That means this availability check is not just checking is port liveness. It is also checking functionality of services, and it is also traffic generation, which is very important for live fire cyber defense exercise. And this is this year's 2025's Apex availability. This year, almost the same, but we had 3 different OT systems: the power grid, and 5G, and healthcare. So it had hundreds of headless browsers running inside of this server. And maybe you noticed that when it shows you the result, it gives you some small text. It gives you some hint whether it's web page is defaced, or if the web service is not reachable, it gives you some hint about it. It has like a router issue or certificate issue. This kind of hint I gave it to blue teams for the faster response. Yeah. And importance of the availability check is the thing that it has one of the biggest scoring budget. For example, it's a live fire exercise that blue teams have services they need to keep up and running. What if blue team turns off their system? Just simply turns off, then red team cannot attack the system. If the red team's attack score is bigger than the availability score, then blue team's strategy will okay, we can just turn off. We don't want to be attacked, and we can take advantage from not being attacked. So it is very important that total availability score is bigger than the red team attack score. So summing up, this availability check is not just checking functionality of the services that blue teams have, and it also have one of the biggest scoring budget. That's why it is important. And to mimic real-life environment, it's very important to generate real-like traffic, not just using call, command, and simple request. You need to use the real web browser so that it make a real traffic. Not just web browser, for all the protocol level access, we need to mimic so that it looks like a real ones. And the visualization, as I showed you before, I found that the observer, if you are a blue teamer or red teamer or green teamer, we know what is happening in the CDX because you are in the network. But we have observers asking, can you show me what is happening? So I thought that this availability check is one good thing to show them. Okay, one of the red team's campaign is degrading blue team's service, and we can visualize them, easy to read for the observers, so that they understand what's going on in this CDX. And also, it is very important to make checks well, availability checks well. If you don't write well, then blue teams will perform so-called evasive tactics. They are interested in get scores rather than focusing on training content itself. That is different from real life. In the real life, maybe usability is more important for the IT systems. But in CDX, because blue teams are very assiduous in defending performance, they wanted to set up that has very excessive security. That could be different from reality. And if it is different from reality, it affects to the training effect. We are doing this exercise for, to be ready for the attack in the real life. We wanted to make the situation same like that is in real life. So it is very important to make real world-like usability check and availability check. And this is the first game net of the Apex. It was last year. We had 3 subnets on the right side with the blue background. And this is the second game net that we had just a month ago. We had the second iteration of Apex. Last year we had 3 subnets. This year we had the 7 subnets with 3 OT domains. Then I want to continue with the cost management. I told you already, the fund allocated to us was not. It was limited, so we need to find a way to reduce cost of using Azure Cloud. At the first, we thought about using reserved instances. We can make a contract saying that, okay, we are going to use these VMs for 2 years or 3 years. Then they will give you, for example, 40% account by maximum. We did this and asking that, can we cancel this contract? They said, yeah, 1 or 2 times is okay. But if you are abusing this cancellation, then you might cannot use this Azure Cloud anymore, because anyways, it's kind of contract. Reserved instance is kind of contract. So it was not, I think it was not suitable for in our case, because we are deploying our systems for 2 teams only in the developing phase. 51 for the green team purpose and 52 for the red team purpose. And when it's time for the Python's run or main execution, we are scaling up to the all teams. So reserved instance does not help for our situation. And we found the other way using inventory. As I told you, I made an inventory that has all the VM information there. If there's a VM does not listed in this inventory, but is in the Azure resource, we show the users like this with the red text. There's an orphan VM, so if there's an owner of this user orphan VM, please list it, add it in the inventory so that we know your VM is there. Otherwise, we are going to erase it. We wanted to know all the VMs in the inventory. We wanted to make sure like that. And in this inventory, there's information about the CPU and RAM disk. Then we can do some calculation, expected cost of using all the VMwares. And finally, we made a service, an additional service, so-called VM clone, that turns off these VMs in the night every day. For every VM, it turns off. And in the morning, it turns on. Because we are using cloud environment, the cost is calculated based on we used. So by using VM clone, turn on in the morning, turn off in the night, by using this, we could use huge amount of money. And we could set this schedule respectively for all the different VMs. For example, the DNS and the routers, they need to be turned on 24/7 so that other VMs can communicate, make a communication. So we can do setup like that in the Brain cron service. So we make the GameNet. So throughout this presentation, I showed you what services we made for making exercise platform. So, and it was possible to make like a small size of live fire exercise. But if you're saying that you have GameNet, you have the exercise platform, there could be a demand that, okay, maybe we can doubling up the size live to make a large scale and the full scale. Actually, large scale means additional service. Full scale means we want to add non-technical content as well. For example, media, law, and the stretch level. Decision-making process level we want to test. We want to do some exercise in this GameNet. Then what is important for further exercise is that we need a sustainable, stable core team so that they can enable this live fire exercise. And it is very important to make a strong community because it's highly likely core team member is small number. But live fire requires many services. Then we need many number of external experts so that they can volunteer their knowledge. For example, they want to make OT system, any services in this GameNet. So this is the core green team technical knowledges. I can just simply, as is time. So thank you for your attention. So if you have questions, feel free to ask me. Thank you.
All right, thank you. Let's take a question if there's any from the audience before I shift to my questions. Okay. I will warm up with the questions from my side. So please do tell me how many VMs in total a single GameNet would approximately hold if you have this number in your head.
You mean the number of VMs?
Yeah.
I think in the Green Team network, I think around 200.
Say again?
In the Green Team network, we had around 200 VMs.
Oh, so it's blue team machines as well, right?
In the blue team, for each blue team, we had like 30, 35.
30, 35.
Yeah.
And how many blue teams were there in the end together? Because I don't think I saw this mentioned, but maybe you can mention.
You mean blue teamers?
Yes. How many blue teams in total there were? Because you just scaled.
There were 8 blue teams.
8 blue teams. So just everything multiplied by 8 in the end. So any particular reason why you chose Azure? Is that because you already had an existing contract, or because it's easier, or you knew how to deploy stuff there?
Actually, at the beginning, this was my first time of using Azure, so I had no knowledge before we chose this Azure. It's simply because at that moment, we didn't have on-premise server ready for this exercise. So choosing cloud environment was the only option.
All right, and live fire means that you also have an opposing red team, right?
Yeah.
So how did you integrate the red team? Were they connecting to the consoles? Were they SSHing into this? How many red teamers were there? How did you spread them across the GameNet as well?
We had around 10 number of red teamers, and they, similar to Laxels, they had their own targets, but because Laxels has many teams, but in Apex, we had only 8 number of teams, so they could handle the 8 teams to attack for their targets.
And when you mentioned about the simulating the traffic or generating the traffic, so what did you exactly use? Did you use some pre-made scripts that would just run the particular service or mimic a user behavior, or did you use traffic generators for that?
I didn't both any traffic generator. I made a script by myself. For example, I used, for example, nowadays I'm using the cursor, this IDE for developing things. And I connected to this cursor with the browser MCP. And using vibe coding is famous nowadays. I asked the AI to, OK, visit this web service and get to know URLs you need to visit. And if there's HTML forms, you need to test it. In that way, I made a script to mimic the user behavior. Yeah.
All right. Well, thank you so much. Let's give a round of applause again for Young Jay.
Thank you.
So we transitioned from a large-scale, well, somewhat a large-scale cyber exercises running at the national scale, down to a smaller, maybe even cheaper exercises. Well, maybe not entirely an exercise. I captured the flag. Please welcome on stage Pēteris Hermans Osipovs, who is one of the core members for the Martiņa CTF. He's been also our partner for CyberChess CTF as well. Well, in general, he is a master student at University of Latvia. He will talk about building and running a CTF. So welcome him on stage with an applause.
So I think previously you should show the screen that I've connected via HDMI on this big screen, if possible. Technical issues? Perfect. So you want to host a CTF. I am Pēteris Hermans Osipovs. I've finished bachelor studies in the University of Latvia in IT, still studying in master's. I've been part of the student council since my first course. I am a hacker at Netcracker, where I identify and help mitigate security risks in company products and services before delivery. If that sounds interesting, we have an open position in Riga. And I've hosted 5 CTFs, where mostly my duties were infrastructure, and I've learned Kubernetes while creating CTF infrastructure. So while in the audience, I assume most of you already know what a CTF is. For those that don't, capture the flag, I would describe it as a hacker competition, where there are vulnerable systems that contain flags. But to access that flag, you need to hack the system. And so you hack the system, you give in the flag as proof that you've hacked it. And hopefully learned something in the process, learned what not to do in the industry. So for infrastructure, what are the requirements? Well, the bare minimum is a system that keeps track of users, the teams that the users are in, the tasks, start, end time, score, and challenges. Preferred is the minimum plus a system that allows you to have tasks running on containers or virtual machines that are isolated from between teams. So let's say that you have a task where you have an SQL injection. You probably don't want all teams to hack on the same machine, because if somebody registers their son Bobby drop tables, then the flag will disappear from the database. So the minimum is satisfied by CTFD, and for preferred is CTFD plus Nomakia or CTFD plus our own system. So CTFD, that is the default screen when you install it. Those of you who participated into CyberChess CTF probably recognize this screen. That is also CTFD, except with their own skin. It performs the basic functions of registering users, teams, tasks, start, end time, and it supports plugins. So if you know how to program in Python, then you're in luck, because you can modify it to suit your needs. What it does not offer is a built-in option to start tasks like containers, virtual machines, VMs, and all that. That's why we need a back-end system. For the first few years in Martiņa CTF 2023 and 2024, we used Nomakia, which performs really well at small scale. What it offers is isolated team networks, a VPN connection that can be either the normal one that you imagine, you just connect and you have an IP address, or level 2, where you can connect and you can actually perform ARP spoofing attacks and ARP spoofing plus man in the middle. So if you change your MAC address and IP address, the connection still remains. Container creation has a ready-made CTFD plugin. What it does not offer? It does not offer VM support, manual task restarting by users. So once you connect to the VM, to the VPN. This task is started, but if there is an issue in the container, well, first of all, you don't really see it in the front end. Second of all, there is no easy way to restart it. You have to talk to the organizers to say, hey, my task died. And yeah, it is not easily scalable across multiple host machines. You can run half the tasks on one server, half the tasks on another server, but that is not preferable scalability. And special thanks to Nadgraph for creating and supporting on Discord. So, what are the requirements for our own system? Well, first of all, we require the ability to be hosted on one or multiple servers. Because in the previous years, our sponsors, well, they were renting server hardware from cloud providers. And for the first time, when you're renting, they told us that they don't give you the beefiest servers. You can get 3 less beefy servers, but you can't get 1 very beefy server. Second of all, obviously, VPNs for connecting to the team networks. We want some kind of way that the participants can access the tasks. And third, allow users to start, stop, or restart tasks. That is mainly coming back to previously. As I said, if a task is broken, they need a way to see that, hey, this is broken, the issue is not on my side, the issue is on the server side. And that can also be useful for specific tasks. So, for example, if you know when the container was started and you know that the container, it's a cryptography task where the exploit is, if you know the start time, you know the seed, and you know you can exploit it, then that is also useful for that. And a simple CI/CD to allow updates during runtime. Nomakia requires you to restart the whole system if you want to update something. And maybe later implement also the ability for not only in Git storing not only the configs for running the containers, but also describing how those containers associate with the tasks in CTFD. Still not implemented yet, sorry. So, question number 1. How do we host on one or multiple physical servers? Well, my answer is Kubernetes, in this case, a K3s cluster. Kubernetes is basically a container orchestrator. So if you have a task that has a front end and a back end, then the container running the front end is one thing, the container running the back end is another thing. Then Kubernetes, you can tell, okay, the participant has access to the front end, he does not have access to the back end. Back end, then you tell through environment variables to the front end, hey, back end is at this IP address, or in Kubernetes case, internal DNS record. So, yeah, Kubernetes API, it's an API that allows you to start, stop containers, create teams, get information about what is running on the cluster. And we use, well, I use Python to receive simple HTTP requests from the participant side. Well, in this case, CTFD. Then, for example, start task 1. Python looks it up in the database. Hey, task 1 needs these containers. They need to be connected in this way. That container has that as an environment variable, and so on. And then I use Kubernetes API library from Python to apply those policies to the cluster. So, VPNs for connecting to the team network. Of course, there are many options for VPNs, but I chose to use OpenVPN for 2 reasons. First of all, Nomakia uses OpenVPN, and our Martiņa CTF veterans already are familiar with it, so they don't need to switch, relearn how to do things. And also, it comes built in with Kali. For creating it on our backend system side, we first create a namespace in Kubernetes, which is logical isolation. Logical isolation in a sense that you cannot have 2 pods with the exact same name, exact same parameters in the same namespace. So if we want to have the same challenge for 5 teams, if it all was in one namespace, well, we would have to add like team identifiers and so on, which is a bit problematic. Then we create a pod running a VPN server. Not a graph. It's just a VPN pod. Apply whitelist network policies. So for those of you who don't already know, in Kubernetes by default, any pod can talk to any pod, which is not preferable in a CTF competition. Then we register users within that pod and store their config in the database. Then we expose the pod to an unused external port. So by default, OpenVPN server uses port 119.4. And, well, we can't have multiple VPN pods inside the cluster and say on the outside of the cluster that, hey, just connect to this 119 or forward. So we expose it to, like, for example, for the first theme, it is 31,001. And we rewrite it in the config, so when they connect to the cluster, the port gets forwarded to their correct container. And then we have a separate API that delivers the VPN configs from the database to the users. So you have a front end in CTFD, they click a button, get config, it adds their team name, username, calls the backend system returns the config, CTFD, well, it's actually through web browser, just creates a file with that content that is returned. And users have a connection to anything within the namespace. So, third, offer users to start, stop, and restart tasks. Again, Kubernetes API. Up here, you can see the post request that is actually being sent to our backend. It contains two variables. Team name, which is 1, because in CTFD, the team names, even if your name is Martins versus machine, then your ID in the database is still just a number. And the challenge name, that is the identificator used to understand what needs to be run on the cluster. So here they look it up in the database, a reversing task, uppermost row is information that could be used for inserting the task in the CTFD. Second row is the pod container image, which contains the link to it, RAM limits, CPU limits, and if it is visible to the user. Then the next one contains environment variables, for example, in this case, flag, and it has the value of the flag. And then the last one is network, how it's defined. In this case, there's only one container, so it's connected to Teamnet. Teamnet, anything that is in that network, has the ability to talk to the VPN pod, or in layman's terms, the participants can access that pod. And then we see that these get applied as network policies to the cluster. Here we go, kubectl get all -n1, get everything from namespace 1. We see that a reversing task is running and the VPN container pod is running. And in the front end, those of you who participated in CyberChess CTF can see that the VPN pod IP is shown and the current running task status is shown. CI/CD, obviously the main goal is to reduce manual steps and make it easily accessible for anyone. We use YAMLs to describe each task. It contains the image build location relative to its location in the Git. So we have a Git, many directories. Each directory is a task. It contains a YAML, and that could contain subdirectories, for example, front end, back end, which contains a Docker file. And in the YAML, we just write /front-end. It knows to look in that directory. It builds the image and puts it in the private registry. So what the Python script does is git pull, iterate through directories, read the YAML files for each task, build the images, insert data into the database. To do is still implement the CTFD API, use the CTFD API to create these tasks actually on CTFD. And to update and fix containers during the CTF, well, if the container is broken, you can just push a new image to the registry and tell participants to restart the task. If some description is wrong, you can just update the task.yaml and push it and ask for somebody to run the update script. And we have a system for controlling tasks in the CTFs. What could be done differently? Choice is made 1. Yeah, that's a Roman numeral, that's not Shakespeare. In case of multiple K3S nodes, how do we handle VPNs and their traffic? So OpenVPN has a beautiful feature called failover, where you can write multiple server IP addresses and ports in the config. And for example, in this case, it's remote server 1, remote server 2, remote server 3. OpenVPN client reads this, tries to connect to server 1. If it fails, it jumps to server 2. If it fails, it jumps to server 3. What are the pros? Well, if one node completely dies, we already have the private keys and we can recreate it on another node. What are the cons? Well, if we want to add a new node, we need to update the client configs. So there is a whole mess of pushing the configs to the participants. We could use a separate node dedicated to hosting the VPNs. We just put all VPN containers on one node, connect the cluster internally with other nodes, and run the tasks on those. Well, for this solution, it's easy to manage VPNs because we know there's only going to be one VPN node. Tasks will probably be the most resource-intensive pods, so it should be easily scalable, especially if you have a memory leak in one of your tasks where a participant actually uploads 1 million checkboxes. The cons are, if the VPN node reaches its limit, it's pretty hard to scale, and all network traffic to the VPN node is doubled because everybody goes to the VPN node and everybody goes out of the VPN node. We could use a reverse HTTP proxy as well to split the VPN traffic. So we have one or multiple nodes that host HTTP proxies. We could write in configs that 1.example.com is the reverse proxy name. When it reaches the reverse proxy, it knows, OK, team 1 is in this node. Why is this beautiful? Because if one node dies or is overwhelmed, we can just change the configs in the reverse proxy to redirect not to this node, but to another node. What are the cons? Well, HTTP proxies is network overhead. So we put traffic inside the VPN, and then we put it inside HTTP. And I think that this is resource intensive, although I have not tried this method yet. So again, in case of multiple K3S nodes, we handle VPN traffic either by writing all node IP addresses, using separate node dedicated to hosting VPNs, or use a reverse proxy. Choice is made too. How do we describe and store tasks in the system? Do we simplify, as I previously mentioned, where we have a YAML file, and we just write everything in there, and to create a task, all you need to know is a bit of Docker, how Docker file works and how Docker containers are built. What are the cons? Well, it's quite limited. So if you have an idea for a task that requires to use all of Kubernetes possibilities, then you might hit a limit with that. Or we could actually allow just writing pod YAML files and replica set files and store them in the Git, and then just pull them, apply them where necessary. What are the cons? Well, in this case, it's easier to harden because we create a whitelist, we check, we verify. It's easier to create validity checks. In this case, we rely on task creators to not mess up because there is the tricky situation. It's a CTF. We want the systems to be vulnerable, but we don't want the infrastructure to be vulnerable. So some vulnerabilities could go a bit deeper than initially intended. So again, we can simplify, or we can specify YAML files to apply to the cluster. Decisions made. We chose to write all node IPs and configs because we can offload the load balancing to the users in that case, and also our CTF is not that big, so we are not expecting thousands of users. And we chose to simplify the YAMLs since when I say we, I mean Datoriti, who host Martiņa CTF, because we consist of enthusiastic students who know Docker. Some of us are very enthusiastic and love Kubernetes. Most of us, not so much. So, demo time. A little bit of hands-on, mainly terminals. I was told this is a tech crowd. So, I have a running system, and I'm just going to demonstrate quickly how it works. So, these are the API calls that CTFD would make to my backend system. In this case, team name is the team ID, username is the user ID. I can click send, and hopefully it will start working. Yep, here we go. Started team and user creation as a thread. Here we can see on the left is watch kubectl get all. So it is just describing the situation in the Kubernetes cluster. Here I have the SQL database. If I run this, oh, it already finished. Nice. So here we can see that up here is the job status, so to speak, because when you make an API call, it starts a job. And when you make another API call for the same team generation and user registration, well, we don't want to register them doubly accidentally. So if there is no entry in this table of the database, then we start it. If there is an entry in the database, then we just read it from the entry and return it to the client. This is translation from generic to internal IDs, and this is just the port that is used. And up higher a little bit is the VPN config. It's just a bit not for this screen. Of course, my fears came through, and the VPN config generation didn't work as intended. 1 second, I'll run it again, and hopefully this time it will work. So, yeah. So the fact that it's taking so long makes me think it is working slowly, because first it generates the VPN certificates. I made a mistake. I'm not that knowledgeable in cryptography. I have a friend in my team who is a crypto fan, and by crypto I mean cryptography, not cryptocurrency. And he told me that, yeah, you're using 248-bit keys, which is a bit overkill. So, will it work? Does it work? Supposedly it's finished. Why am I not seeing any action? Of course, my connection to the server has died for some reason.
Well, this is live demo, right? Just when you're trying to fix this, just walk through the things that go through your mind as well, like why you're doing a particular thing when you're fixing something.
Yes. So in this case, I'll assume that it is running on the cluster, but I don't have access to the cluster, but I have APIs. So team 5, I can see. So you see team name number 5. I generated team name 5, username 5. Get namespace, get all pods in a namespace. The fact that it's showing VPN container pod is running, that makes me think, okay, maybe it's working. I can try to get the user VPN config through here. If it is, well, working, then I can see, yes, it should be the correct one, because we can see that 31,005, since the team name is 5, it should be port number 5. So, let's hope that it connects. Yes, initialization sequence completed. We have successfully generated a team. Now, okay, I'm connected to the network. What can I do? I have a get challenges API that shows me all the challenges that I can run. That is used by CTFD frontend to display the available challenges. I can try this challenge, needles in a haystack. Just have to send an API call, needles in a haystack. Team name is 5. Send. And to get the status, I can just resend this request, and I can see, hey, it's running. The reason why visible IP is 1, I also have implemented kind of an admin API where you can see invisible APIs, which are not shown to the common users. This task in specific has a VPN backend. But we can check if it is working. If I can ping it, I can ping it. I can run curl since it's a web task, and here we go. We can see the website. Somebody in the audience probably can already imagine what it looks like from HTML code. But yeah. And if I want to stop the challenge because the limit of challenges that I can run is reached, I can just send an API call to stop challenge. I get namespace. It is still showing as terminating because the front end has to know that, hey, this still hasn't finished yet, so that they can't just start a lot of tasks, stop a lot of tasks immediately. And that is pretty much it from the demo part. Thank you for your attention. This info will be available on GitHub after Martin CTF, which should be end of November, beginning of December. I'll probably post about it on LinkedIn, so if you want, there is a link to my LinkedIn. And this was my first time speaking at a conference, so special thanks to Bernhard for allowing me to be here. And do we have any questions?
Sure, let's take the questions from the audience, if there is any. If there's none, okay, for now. Let's warm up. Maybe the people will start generating questions. I'm also checking the Menti as well, so you can post your questions online. I will try to assess them as well and ask them. Now, Petrs, you and your team have been engaged in assisting the CyberChess CTF as well, working together with the Hackfest. Can you just give the highlights of how easy it was to integrate? What were the challenges? What did you have to solve that hasn't been solved before to make this happen?
So first of all, I'm really happy that Hackfest is also using CTFD. So it was really easy. I have a CTFD instance on my own. I have a plugin. I just tell them, hey, can you git pull, push the plugin on your side? I see it. OK, it's working. Well, OK, there were some niche issues, but we fixed it. It was really easy. Also, they are extremely knowledgeable and forthcoming. So it was a really great experience to host a CTF with somebody who's done it for years and years and years. From our side, we needed to create the infra. And we faced an issue, well, I faced an issue that I hadn't faced previously. My highlight from CyberChess CTF was I thought that the limit for our infra is the /24 network. Theoretically, 255 IP addresses, some are reserved, roughly 250 IP addresses. I thought we were going to run out of IP addresses. Apparently, Kubernetes by default sets the amount of maximum pods that you can run. And to change that, you need to restart the cluster, which was a fun experience.
So what did Hackfest team learn? Because I know that they learned something from you as well.
Well, we exchanged experiences because, of course, they're using CTFD, we're using CTFD, we're doing it as students, they're doing it as professionals. And it's just, in general, how do I put this? The difference in experience and knowledge, because we're still mostly students, and they are mostly industry professionals. So how we look at things, how they look at things, it's just a beautiful chance to see the world from a different view.
All right, if there's still anyone that wants to ask the questions, you're now your time. Furthermore, I mean, you're running these challenges, the Martiņa CTF and offering a CTF already for some time. So how often do you do this, and what is your target audience, and how big is your target audience usually?
So Martiņa CTF, the first one happened in 2023, November. We had now roughly 80 participants, which actually was a big surprise for me. I thought like 30 people max. No, 80 people came to our CTF, and in person, it was beautiful. Then in 2024, we had a second Martiņa CTF. Already, I saw people from all around, from across Latvia, but we also saw some from Estonia, some from Lithuania. We had the team from Denmark. Yeah, 170 participants altogether. And after that, we started the University Cybersecurity Club, where we host our own mini CTFs, which I mainly use for testing infrastructure. So we had one in this year of April and this year of September that we did like the general maintenance, the huge test before CyberChess for our infrastructure.
All right, I do not see any hands being raised for now. Let's give a round of applause to one of the core developers of Martiņa CTF. Do you have a name of Martiņš as well? Because I know everyone has a name of Martiņš at the Martiņš CTF.
Well, since we decided that in the first CTF, well, of course it was a temporary name, and as we all know, temporary solutions that don't break become permanent solutions. So I was in that meeting where we decided we're going to be Martiņi. I got lucky. I'm Martiņš1337.
Good choice. So thanks once again, and I'm so happy that we have such brilliant students in our universities. Thank you.
Thank you.
Well, wait.
Yeah. Oh.
A pair of socks for you.
Oh, thank you. I hope we won't be needing a sock for our CTFs.
With this, thank you everyone for being part of the yet again amazing experience of CyberChess and being here with me, with us, with the speakers, with you, the engaging audience on the CyberShock stage, our technical track. With this, I say thank you for being part of this, and well, we are transitioning to the main room for the closing procedures. With you, I'll see you soon. Bye-bye.